Hello and welcome back to Blackbird. This is Venkat, and in this video, we will be talking about classes and objects in Java. Now, starting on from this video, we'll be understanding some jargons, we'll be dealing with some tough words which are harder spelled than written. So, embrace yourself for this journey, and let's not make it dramatic. This section will be interesting if you really pay attention to it. So, starting off with classes, we already have been using them all the way around in our programs. Classes have been since the beginning in our course. However, until now, it's just a very basic form of class that we have been using. It just exists so that it can encapsulate the main method within it. But now, classes should be understood as something more powerful than just an encapsulation unit. Perhaps it's high time we understand that class defines a new data type. It itself is a composite data type. Well, but what is composite type? We have already heard about primitive and reference types. So, composite data type comes under the reference types only. It is a combination of primitive plus reference types. Since you will have a lot of other classes and interfaces within the class itself, and that is why it is a composite data type. It's also an abstract data type. Class is also an object factory. Did you know that? How is it so? Well, class is an object factory not because it can be used to declare objects, but it can be used to declare the same kind of objects. So let's say that human is a class, okay? Within this class, I can have different people. I can really say human Adira is equals a new human. I can really say var Venkat is equals new human. Oh, well, don't worry about this context sensitive keyword. Not a keyword, but a reserved word, var. It is done in order to reduce the redundancy. You can really check out the video that I have on local variable type inferencing. We have already discussed this before. Talking about these two examples. So let's say this is the human class and it has age, it has height, it has behaviors like eating and sleeping. All of this is within these two instances of the human class, one named Adira and the other named Venkat. So by default, all of these parameters, the behaviors and the attributes, all of them are present in both Adira and Venkat by default. And that is why a class is called an object factory because it can be used to create same kind of objects over and over again. Moving on, let us now discuss about the general nature of a class or a general format of a class. In case of a general form, I'll just give you a syntax of it, and it is something like this. We have the class keyword followed by the class name and then the scope of the class. We have the data type, we have instance variables, then we can really have multiple instance variables of different types. We can have global variables, after which we have a constructor. We'll talk about all of these data elements one by one. Let's say the constructor is okay. Then we can have methods which define the behavior of a class. And then the body of the method. and in this way we can really have till like method n. Within these methods we can also have parameters that really depends on you and what kind of methods you are using, and then that's it. So this is a general format of a class. Now let us discuss and break down all these terms in a simpler manner. Every class begins with this class keyword followed by a class name, and then there is a pair of curly brackets which denote the scope of the class within which all the properties and behaviors of a class would be enclosed. Then here we have the data type and instance variable 1 to n, whatever you can have it. Now, why are these called instance variables? Let us discuss that. There is a really good story behind this. Once you declare all these instance variables or variables within the class scope, what happens is every every instance of this particular class will have a separate copy of these instance variables. Okay, I hope you do not understand anything. Don't worry. Let's say I have a human class and I have age, I have height, I have name, and I have weight in this human class. Now, in the last example, we created two instances of this human class, one with name Adira and one with the name Venkat. Okay. Now, these names are also pointing to some object which is of the type human. Similarly, Venkat also points to some object in the heap memory of the type human. And both of these two instances of human class have different age, have different height, have different name, and have different weight. So, if Venkat tries to go to the gym and if he reduces his own weight, I can really say Venkat dot weight minus minus, there would be no change in Adira's weight because they are two separate humans. Okay, so all these properties that are there in the human class, the in age, name, weight, and height, all of these are instance variables. There is one more thing. Do not really mind if we use instances and objects interchangeably because they both mean the same. Okay. Now, we have this global wars. What are these? These are basically global variables. These are specifically those kind of variables which a class has only one copy of. So let me write it down here. So global variables are variables which a class has only one copy of, which is shared among the instances. So this is something that you really need to know, that global variables are variables which a class has only one copy of, which is shared among all of its instances. What can be a good example of a common thing in both Adira and Venkat or in any human being? A good example of global variables in the human class would be the species. Now, all human beings belong to the species named Homo sapiens, and it is constant for all of the human beings. So, how to declare a global variable? That is the first question. And how does it differ from the declaration of instance variables? Well, there is just one difference, and that is the keyword static. Once you make a variable static, that too in the class scope, it means that the particular variable will have only one copy whatsoever number of objects be created of the same class. The use of keyword static really matters here because then you are actually telling to the compiler that you just need to have one copy of this variable species be stored in the human class and only one copy present in this human class would be shared among the instances of the human class. So it'll be the same for Adira, it'll be the same for Venkat, or it'll be the same for any number of instances you create for the human class. Now you can really declare instance variables and have modifiers in front of them as well. So in case of a declaration of an instance variables, we can really say that some instance variables can be public, so public int age. But let's say if someone wants to hide their age and only reveal it when they need it, in that case, we can say that the age can be declared with the help of the private modifier. You won't see the changes right away, but when we'll see it in the practical, I'll show you how these access specifiers or modifiers, whatever you call them, alter the visibility of this variable age within the package and outside of the package. So this is something really important. Okay, let's say you really don't want anyone to change your age because obviously it is not changeable. It's a process that happens every year that you just increase your age once after you are born. So in that case, using the private keyword is really helpful. In the same way, you would have things for the other properties of the human class, like private string name, private int height, and weight. Now, this is a concept of encapsulation. This ensures that your data is within the single unit. It's not visible outside of the class unit. So it's an example of encapsulation and data abstraction. You'll only make things visible which are required to be visible. Moving on, let's talk about constructors. What are constructors? Well, a short answer, constructors are used to initialize the data members of the class or the instance variables of a class. We'll learn about constructors in the video where we'll be discussing about methods. So, not in this video, but in the next one. Talking about the methods, you have already seen one method, which is the main method. We'll talk about other kind of methods as well. But let's finish off with the classes. Now let us create a human class. Okay, let us just plan creating a human class with the properties like age, name, height, and weight, and behaviors or like the actions that this human class can perform to be eat, one of my favorite, sleep, which is my favorite, but then that's not possible, and let's say workout, which actually does not happen for every human, and I think this will be enough. Three actions and four properties. Okay, we have to create a class out of it and create two instances, and then we'll understand the use of new keyword once again in this video. So let us move on to IntelliJ. Let me just create a class. As usual, my IntelliJ is really slow, does not really do this. Oops dot human. All right, I think I should enter the presentation mode. Yeah. Within this public class human, I said that I want to have these four parameters. So I'll have private int age, height, and weight. I should say that the weight is a double quantity, so I'll have it in as a double type. Private double weight. Then I'll say private string name, and I also have a global variable saying that it's really a species which all the instances of a human class can access, but they cannot change. Okay, seems good enough. Now you might see that public, static, and final are all access modifiers and as well as modifiers. Especially public is a access modifier rather than the rest of them are modifiers in general. This public keyword denotes that this particular species variable is accessible outside the package oops as well. Which is like accessible outside the folder of oops, given I access it with the name of the class. Static talks about that there is just one instance of species that should be present throughout the n number of instances of the human class. Final, it again states that species is non-modifiable, you cannot change it, and it's a constant. Okay, now let's have a constructor saying human, which will help us initialize all these name, age, height, and weight properties. So let's say int age, int height, double weight, string name. All right, looks good. I can say, and for this point, let it be like this. Let me just say that to do initialize the data members or properties to human class. Okay, now let us move on in order to declare our methods. I'll say public void eat. So I'll print name plus is eating. All right. So what I'm doing here is I have a method public void eat, okay, with the name of eat, returns a void type, which is basically specifying that it does not return any type, it just performs some operations, and it's set on a public accessibility so that it can be accessed using the instance of the human class. And within this method, what we are saying that that the name which has been given here, that person is eating. Now the same way I'll say sleep, I'll print name plus is sleeping. There is a separate way of writing it. You can also write it in this way: system.out.println, and you can write string.format, and within the parameters you can write mod s is sleeping, and here then again you can give a parameter such as name. This will work exactly fine if I uncomment this code. So you can also do this. Let's just keep it with this. Let us remove this one. Now the other is workout. In the same way, I'll say system.out.println string.format and mod s is working out, and then I'll give a parameter such as name. All right, our class looks good to go with. So let's have a other class named driver. Okay, this is just a driver class. Okay, you shouldn't misunderstand as it is an implementation of the human class. It's not that. This class has a main method which will help us run the program. What I can do is I can really instantiate a human being. So I can say human Adira is equals new human, and human Venkat is equals new human. All right. So in case I call adira.eat or venkat.eat, I get a sort of an error. Why is it so? It's because that we are expecting 4 arguments in the constructor, but we barely specified anyone. Now, since you're instantiating Adira as a human being, you need to mention the age, height, weight, and the name of the person so that this particular human class can store all of those things in these instance variables for the Adira instance. So, firstly, we have age, I suppose. So, let's say 12. Then we have height, let's say 157 centimeter. Then we have weight, 65. And the name, which is Adira. And the same way, we'll have it here 18, 172, 71, no, 72, and Venkat. Okay, this looks fine enough. What else do we have to do? Let us just execute this and test what it prints for us. Okay, so once we execute it, we see that we get a value of null is eating and null is eating. Why is it so? Why are we getting null? Null is the default value for a reference type, and the reference type that we have here is string, that is a name. But didn't we pass the parameter to have or like save the name of Adira and Venkat in this human instance? No, we didn't. We actually passed the parameters to the human constructor, but we did not initialize them with this particular name. So in this case, what I'll do is I'll say this dot age is equals age, this dot height is equals height, this dot weight is weight, and this dot name is again name. I forgot that it's a double type, so 0.0 is important. Okay, what is this particular keyword? This. Let's talk about it. Now, you have the human class. Okay, let's say here at this point of in this place, you have the age as a local variable. For the scope of this constructor, age is a local variable. But here in this human class, age is a instance variable. So the compiler is confused. If you omit this keyword, the compiler is confused. Which age are you referring to? Is the local variable equals the instance variable, or is the instance variable being assigned the value of the local variable? In order to resolve this, we use the this reference variable. It's a reserved word. Let us see what it exactly means. So this is basically a keyword used to reference current class properties and methods. So as we discussed, we have this constructor public human, and let's say it just has one parameter right now, int age, and here we have a instance variable with the name of age. What we are doing is we are writing this dot age is equals age, and then constructor's scope ends here. So at this point of time, local variable with the name of age has a higher precedence than the instance variable, which is also named as age. In order to avoid confusion and to implement data hiding or data foreshadowing, we use the this keyword. Now you might have seen that the way we are using the this keyword, it happens to be that somebody has already instantiated our human class for us without our intervention, and has provided us with the object which is being stored in this keyword. And that is why we are able to access all the properties and methods, or like the actions that the human class has. So if you had seen, what I wrote was this dot age. But you might have a question. We generally do this when we have instantiated some object like this here, as we have done it. And it's exactly the same way we are doing it there. Instead of this Adira, we are using this. Now, why is it so? It's because it's a reference variable. It stores the reference of the human class. So let me write this down. This keyword stores the reference of the current class. All right. And that is why we write it something like this, so that we can simply tell the compiler that there is this local variable age which has some value within it, and there is this age which is an instance variable. So human.age, like the instance variable age, should be assigned with the value that is stored in this local variable age. And that pretty much brings us to the topic that why exactly should we use the this keyword. It's much more readable in this format than to confuse the other person who is watching you program or watching your program. So I should really say that you should really use this kind of syntax in order to refer a instance variable or a method that is the part of the class that you're accessing it in. Okay. Now let's move on to where exactly we were. Now let us execute this program and let us see what the output would be. Now we are finally getting that Adira is eating and the Venkat is eating. Well, I'm not eating, I'm talking, but it's okay. It's a program. That's not a matter. Now when I have done this, when I have let's take a closer look at line 33. Okay. What I've said is human, and then the name of that variable which would store the memory location to Adira's properties and behaviors is equals new human, and then we have passed all the parameters here. After passing the parameters, do you know how it actually looks like in the heap memory? Let me show you. So let's say we have written that thing in the heap memory. It'll something be like this, where this is a human type, and it stores in its properties or the instance variables a string which has the name Adira, age which is I think 12, height is 157, and weight is 65.2 because it's a double type. So this is how it looks like in the heap memory. Similarly for Venkat, things remain the same. It also points to a human type, okay, with the name that is Venkat and all the rest of the properties as it was. Now let us understand what happens when we actually create an object with the help of two statements. So let's say in the first example, I just said human Adira, and that's it. This is one. And the other, let's say I actually said human Adira is equals new human, and then I gave all the parameters that are required in order to initialize a human named Adira. Okay. Now for the first statement, what the compiler does is there is a variable which is created in the memory, but then this reference variable does not point anywhere in the memory. It's just a variable that is created. And the second object, like in the second line, what we get to see is we have this reference variable Adira, which is pointing to a memory location in the heap where we have created a human instance with the name Adira. You know, the name, weight, height, and the age. So all of these parameters. So there is a difference in declaring something and then actually instantiating an object of that particular type. Now let us take another case study. Let's say a box, and within this box, what we have is different types of boxes, like a square box. We can say a rectangular box. Okay, so these are the different sizes of the box that we can really have. This box, since it's a 3D object, okay, like physically speaking, it's a 3D object. So for 3D objects, we have width, we have height, and we also have breadth. Okay, so these three parameters are there for any kind of a 3D box, and a 3D square, or like a 3D box which is made of six squares, means a cube, and same for the rectangle, it's a cuboid. Now in order to create a box object, what we need to do is really simple. We'll say box, my box is equals a new box, and I'll initialize the parameters. Let's say width is 10, height is 20, and breadth is 30. So it's a rectangular box clearly. So after creating this one box, what happens when we compile this? What the compiler does is, let's say this is the variable, reference variable my box. It stores the memory location for this particular box instance here in the heap memory. Okay, which has the parameter width, height, and breadth. So it has these three things, and this is what happens when you compile this program. Now let's say that I want to have the same box, but I don't want to create any instance. You know what I want to do is everything remains the same. What I want is another box. Let's say my box 2, and then I say that, I already have, since I already have the box with these dimensions, I'll create, or I'll basically assign this my box to the reference variable my box 2. So let's see what happens. After you compile this, what happens is there is just one instance that is there in the heap memory with the width, height, and breadth. But the catch here is this mybox reference variable points to this instance, and also the second mybox 2 reference variable also points to this particular instance instead of creating a separate or a new instance of the box type. This is called assigning object reference variables among each other. So although box and my box 2 both refer to the same object, they are not linked in between. Like there is no linkage in between of this reference variable and this one. So let's say if I make b my box as null, so this link would be set to null. This my box reference variable won't be pointing to this box instance, but again my box 2 would still be pointing to this particular instance in the memory. So setting 1 to null won't affect or won't have any change on this particular reference variable, and it won't even destroy the object unless these both the reference variables are set to null. But let's say that I want to change the breadth of the box for the first instance, that is my box 1. What I would say is I would write my box dot breadth is equals, and I'll assign a new breadth value to it, and that will be 15. Okay. Now when I do this, the breadth value here changes to 15. The height remains the same, width also remains the same. And now if you try to print out, so if you try to print what is the breadth of this my box 2, so you would get a value of 15. This is why, because this is because you have assigned my box to my box 2, and they both point to the same instance in the heap memory. They point to the same address. So making a change here in this one address will also be reflected, since there is just one instance which both of these reference variables are pointing towards. And this is the reason if you invoke any of the parameters here after assigning them like this, the change will be reflected in both the reference variables till the point they both are pointing to the same instance in the heap memory. So I know this can be a little confusing at times, but you just have to think that using a new keyword, if you create an instance using this new keyword, what will happen is there, even if you say that every parameter remains the same, it will create a new instance on the heap memory, and then that mybox2 instance will be pointing to that new instance, and any changes made there won't really reflect on the previous instance of my box. But since you're assigning it here, you're assigning the instance, you're assigning the address to my box 2, both of these reference variables point to the same object. So making a change via one reference variable would reflect the changes in the other as well, because I mean the object is same, the memory location is just shared between these two instances. This brings us to a conclusion that when you assign one object, or like one instance reference variable, to another object reference variable, you are not creating a copy of the object. So basically, you're not creating a copy of the object. You are making a copy of the reference. This reference is also the memory address that we were talking about, the memory location on the instance on the heap memory. So keep this thing in mind, because this is something really important, and it has been in a lot of certification exams that this question has confused even the um, best programmers out there, because they did not know about the intricate working of objects and classes and the new keyword. Okay, now let us talk about constructors a little. Like what are constructors, and why exactly use them? What are the types of constructors that are present? So basically, constructors can be understood as methods, but they're not exactly methods. Okay, the sole purpose of a constructor is to initialize the object immediately upon creation. So if I talk about the purpose, It's to initialize the object immediately after creation. There are a lot of instance variables and global variables, and there might be some functions that you need to perform right after the object is created. And that is why constructors offer us this feature that you can really define all the values, all the predefined values or the default values for the instance variables that you have in your class, as well as you can also call in or invoke some methods which are required to be executed right after the creation of an object. Now constructors look a little strange. Why? Because they do not have a return type. They don't have a return type. And but this I mean that they don't even have the return type set as void. You generally see that where we don't need to return any type, we mention void, that there is no return type for this method. But constructors don't even have void return type. It is because the implicit return type of a class's constructor is the class type. So let me write this down, that the implicit return type of a constructor is the class type itself. So if my constructor is present in the human class, it'll return the human type. It won't return some animal type. Okay, don't worry about that. Now, there are a lot of types of constructors that you'll come across in your coding journey. One of them are default constructors. Let's say that you have created an object-oriented program. I hope the spelling of the constructor is right here. Let's say that you have created an object-oriented program, or you have just created an object, and you forgot to have a constructor. So let's say I have a class box. I have the instance variables here, and then in the main method, what I say is box1 is equals new box. So this right here is a default constructor. No, not the semicolon, but this right here, the box, then a pair of parentheses is a denotes a default constructor. Even if you don't have a constructor in your class, what the compiler does is it creates one by default. That has been from the really start of Java programming. So the compiler says that if you have forgotten a default constructor, it's okay. I understand that you want to initialize the instance variables of the box class with their default value, so I'll do that, no issues. So this is implicitly created by the compiler. Let's say that you actually have a constructor. In that case, you need to have a parameterized constructor. So let's say that you actually decide to have constructors in your class and you also have instance variables. In that case, you need to have at least one parameterized constructor which is used for initializing the data members, like the instance variables, of course. An example of parameterized constructor is something that we have discussed in the previous slide. So, you can rewind the video in order to have that example where we used all the parameters like age, weight, height, and the name to initialize a human. Okay. Now there are other type, which is a non-parameterized constructor. Sometimes it can be thought of as a default constructor, but if you're not using it for instant, like initializing the instance variables, you can really perform some work or some actions. You can invoke some methods which need to be invoked right after the object is created. And the last type I think is a copy constructor. Well, this is something that I'll love to discuss in some other video, not right now because we have not covered the topics of passing object in a method. Since I'll be covering that in the next video, where we'll be taking a closer look in the methods and constructors, we'll talk about copy constructors there. For now, you can just understand that copy constructors are used to, initialize some other values, like initialize one object with the values of the other, with the properties of the other. So like let's say I have a box 1 and I have a box 2. A box 1 stores the width, height, and breadth. What I want is I want a new instance in the heap memory. So but I want that it should have the same properties, and it should have the same dimensions as the box 1. So what I'll do is I'll actually pass the box 1 into a constructor as a object, and what I'll do is I'll assign the dimensions of box 2 by taking in the reference variable box 1 in order to assign, and then basically access the instance variables in the box 1 instance in order to initialize the box 2 instance. I know it's a little confusing, but we'll talk about it in detail in the other video. Well, there is one last thing that I will love to talk about, which is garbage collection. Although garbage collection requires another playlist of its kind, but I'll just talk about it in really brief. So let's say that you want, in different objects, in different languages, you have this feature that, they have their own memory management systems. So like in C++, you have a deallocation process. So, you can use that in order to dereference a object that is present in the memory. So you'll have to do it your own self. Memory management is manual in case of C++. But in Java, Java says that, I love to take things in my own hands, and that is why Java has an efficient memory management system. So why this is efficient? It is because, let's say that I have an object box 1 is equals new box, and then the parameters, let's say, width 10, height 20, and breadth 15. So what this does is it creates a reference variable box 1, which stores the reference to a box which is present in the heap memory, which has a particular width, height, and breadth. Now let's say I set that box 1 is equals null. So when I set this, the link between, like, the reference that this particular box 1 was storing has been deleted by the compiler, and it has been set to null. Okay, so what happens is the compiler sees that, there is an instance present in the heap memory of the box type. So let us mark this. Let us mark this, or let us basically flag this, and then in the second iteration it checks that, if it has already been marked and if there are no reference variables pointing to this particular memory location, it basically uses the sweep method to remove this object from the memory, like remove this instance from the memory. And that is how objects are destroyed by the Java compiler. So when no references to an object exist, that object is assumed to be no longer to be needed, and hence the memory occupied by the object can be reclaimed, and that is by using the mark and sweep methods, the garbage collection happens in Java. There is also a method as system.gc which invokes the garbage collection. You can say system.gc, like it's like invoking the garbage collector manually in Java in order to dereference an object. Or let's say that you actually want to have a weak reference to a particular object. In that case, you use the weak reference class. If you want to know more about it, comment down weak reference, and I'll actually create a video upon that where we'll be talking about this particular thing and garbage collection. So if you comment this, and if there are more comments, I'll actually create a video on this one. But that is it for this video. Thanks for watching.